Hello everyone and welcome back. Today we want to talk about special matrices. That is, some matrices that are known and very familiar, that they have their own terminologies. So the first matrix that we are going to see is called the zero matrix. So what is a zero matrix? A zero matrix is a matrix where all the elements inside that matrix is zero. Let me write that up for you. Let's say you want to have a zero matrix of order, and yes, it is important to specify the order. Let's say order of 2 cross 3. This is the thing we want to see, and let's say we call it A. You have 2 rows and 3 columns. So this is our zero matrix. Now let's take a look at another example of another special matrix, and it is called a square matrix. This is our second example of a special matrix. Square matrix. So in general, a matrix can have order of m cross n, right? But what if, that is, what if m equals to n? So if that's the case, this corresponds to order of n cross n, and these are the matrices we are calling square matrices. Again, let's take a look at an example. Let's call this square matrix S, and let's say we want n equals to 2. That is a 2 cross 2 matrix. So you can have 2, 1, 0, 3. This is a square matrix. Again, you can have a 3 by 3 square matrix, writing as this: 1, 2, 3, 0, 9, 1, 6, 7, 8. This is also a square matrix. However, note that if we had, let's say, L equals to 1, 2, 3, 0, 1, 6, this is not a square matrix. And the reason is very clear, that here the number of rows and the number of columns are not equal. So that's why we are calling it that this is not a square matrix. Okay. Now, inside a square matrix, you can have something called a principal diagonal. That is, let's take a square matrix again. Let's write it as small g, and you have 1, 2, 3, 3, 6, 7, 8, 9, 15. The principal diagonal is this part that I'm highlighting right now. This is called the principal diagonal. And the elements, that is 1, 6, and 15, that this principal diagonal carries, these are called the diagonal elements. Now, how do we denote for a general matrix? That is, how do we denote the components or the entries that we have for a general matrix? Let's say for this G, I want to know the I and the jth component, right? So, and this is how we write it. Let's say I want to know the 1, 2 component. What is that? So if we write it like this, Oh, sorry, I have written 1 and 2 inside. It shouldn't happen. It's G12, and the 1/2 element is 3, right? And the diagonal entries, let's say you want to write G11, this is 1. This is just a reminder how we have written our matrix elements in terms of the components. Okay, now let's move forward. Now we will talk about another matrix called a diagonal matrix. This is our third special case, diagonal matrix. Oh, excuse me. Say you have a matrix called D, and let's take a matrix of order 4 cross 4, and you have it like this. You can see that on the principal diagonal there are non-zero elements, but the rest of the elements are 0. So this form of a matrix is called a diagonal matrix. Now we want to take a look at something that's called upper triangular matrix, upper triangular and lower triangular matrices. Let's denote the upper triangular matrix by U, and let's say you have 1, 2, 3, you have 0, you have 5 over here, 6, 7, 0, 0. You can see that if I indicate the principal diagonal, along this line there is a triangle on the upside. By triangle I mean there are non-zero elements, and on the lower side these are all zeros. So this is called an upper triangular matrix. Upper triangular matrix. And let's denote our lower triangular matrix by L. So we are again taking an example of a 3 by 3 matrix, and a lower triangular matrix of order 3 by 3 will look something like the following. Again, notice that we are taking a 0 in our principal diagonal, but it won't matter because as I write the next elements you will understand why. So again you can indicate out the principal diagonal, and you can see that on the lower side of it you have some elements that are non-zero. At least I have 2 elements that are non-zero, but on the upper side, that is on this side, all the elements are 0. So that's why it's called a lower triangular matrices. Lower triangular matrix. And we would like to finish off by seeing the last example for today, and we are calling it the column matrices. You have seen column matrices, but the reason I am discussing it here as a special matrix because this column matrices, let's say E1, it's a column matrix, let's say 1, 0, and I have another column matrix called E2, 0, 1. These type of column matrices are special. Why? Because they serve as a basis. The term basis will be discussed when we talk about vector spaces. At this point, I just wanted to give you guys a little spoiler that this type of matrices are actually basis vectors. So that's why I discussed it here, and I hope you enjoyed it, and I'll see you guys on the next lecture. Thank you.